Greetings and salam sejahtera. This is the presentations of Bachelor Degrees Project 1. My name is Sebastian and my matrix number is AD180040 and my respected supervisors is Dr. Sarifa Atzila and Kished Abu Bakar. My title for Bachelor Degree Project 1 is the characterizations of polyhydroalkanoids, PHA, nanocalcium phosphate, NCAP, ketosane CH composite for bone tissue regeneration. I propose the presentations of Bachelor Degree Project 1 to my panels for the evaluations, which is panel number 1 is Professor Madya Dr. Anika, and panel number 2 is Professor Madya Dr. Hassan Yehudi. And this Bachelor Degree Project 1 is based on Jabatan Kejuruteraan Pembuatan JKP. For Chapter 1, Introduction, there are 5 items for the outline of Chapter 1, which is first is background study, second is problem statement, third objective, fourth scope of study, and lastly the element sustainability. Whereas for Chapter 2, literature review, there are 7 items for the Chapter 2 outline, which is first is bone tissue engineering, second is scaffolds composite, third is PHA, fourth NCAP, fifth CH, sixth thermal properties, and lastly the microstructure. For Chapter 3, methodology, there are 6 items for the Chapter 3 outline. The first is project flowchart, second is material, third is preparation composite, fourth is SEM, fifth is TGA and DSC, and lastly FPIR. The characterizations of biomaterial composite is focused on the bone tissue regeneration. So, what is bone tissue regeneration? So, bone tissue regeneration is actually described as a process of bone formations and continuous remodeling by the bone cells, which is in the formations described as a complex and well-orchestrated physiological process of bone cells. So, why this bone tissue regeneration must be occurred and must be happen? This is because due to the very serious severe conditions of medical application, especially for the bone defect. So bone defect such as avascular necrosis and atrophic non-union, and especially for osteoporosis, is actually a very serious conditions for bone defects. Besides of bone fractures, small bone fractures, it is very different with the bone defect. How bone tissue regenerations can be happening? So, bone tissue regeneration can be happening through engineering. So, bone tissue engineering may modulate bone recuperating the mirrors of the extracellular matrix framework, which is known by ECM, and by this the biodegradable and biocompatible materials such as PHA, NCAP, and CH is actually provide suitable for measures porosity, mechanical properties, and osteoconductivity. So what biomaterials such as PHA, NCAP, and CH in this bone tissue engineering? For example, of single-phase scaffold such as PHA, this is not give an appropriate auxiliary and mechanical properties for bone tissue regeneration, because single-phase scaffold such as PHA alone has its weaknesses such as high degree crystallinity, and this is make this scaffold composite not really suitable for bone tissue engineering. As we can see the figure in the slides, these figures is the illustrations of bone tissue engineering, and as you can see that the bone defect can be solved through grafting bone or implantations of bone through scaffolding bone tissue engineering. So scaffolding can be based on biomaterial, which is from ceramic, polymers, or composite materials in order to form a biomaterial scaffold. So these scaffolds can be added and loaded with the cells in order to form a new bone tissues for the bone tissue engineering. Next subtopic is the problem statement. The problem statement for this bachelor degree project 1 is on based on the title. So first is the PHA. The PHA, why the PHA? Polyhydroalkanite is alone described as insufficient composite to support bone regenerations, and because it is actually have high degree crystallizations and state, and due to the degree crystallinity, it will be easily brittle. And PHA is actually from synthetic polymer composite. The next is calcium phosphate. Why we need to adding calcium phosphate into PHA? Because the implications of calcium phosphate into the PHA is quite relevant because these materials actually able to improve the mechanical stability and the bioactivities for the scaffolding engineering. And next is the CH, which is the cytoxan. So cytoxans also serves with the PHA, which is CHA is based on natural ceramic, and cytoxan alone has a low bioactivity and mechanical characteristic. So to solve this, it must be combined with other natural polymers such as PHA, and cytoxan also takes responsibilities as a binder materials in scaffolding. So next is nanoparticles. So nanoparticles, in here is the integrations of the calcium phosphate. So nano-sized particles is able to improve mechanical and biological characteristics. So we actually applied the nanoparticles into the calcium phosphate, transform it into nanoparticles of nano-calcium phosphate. It is because using nano-calcium phosphate in this scaffolding is actually in order to improve the distributions on the surface, which is more equally distribution of the surface. Next subtopic is the objective. The objective on this project is actually three. The first is to prepare PHA, NCAP, and CH through melt blending process using injection molding method. So next objective is to determine the thermal properties of PHA, NCAP, CH composite in various percentage, and lastly to examine the microstructures of PHA, NCAP in composite. For the determination of thermal properties is actually from using the method of TGA and DSC, where the excitation of microstructures for biomaterials is based on scanning electron microscopy method and FTIR. Next subtopic is scope of study. So in this project, there are three stages for the project. The first stage is the blending of PHA, NCAP, and CH. As we can see the table here, there are 5 samples required with various and different weight percentage of each respective biomaterial, and each of the sample will be blended to the respective designated percentage and the rest of the sample. The second stage is the determinations of thermal properties of PHA and NCAP, CH composite through using TGA, and DSC method. And lastly, for the stage 3 is to examining the microstructures of biomaterials, PHA and PHA and CFP-CH composite. For stage 2 and stage 3 requires the finished blending of biomaterials, and it's actually already crushed for future characterization. Next subtopic in this chapter 1 is the element sustainability. So element sustainability is actually important in this project. It is because it will provides a continuous insights for the institutions, individually the societies, of the applications and use of biomaterials, which is focused on bone tissue regenerations. And second is will expose the knowledge of the application of bone tissue engineering in medical terms. And lastly, in order to discover the properties of the applied biomaterials and how it will be beneficial to the bone tissue regeneration. Next, we will enter the chapter 2, which is the literature review. For this subtopic number 1 is based on bone tissue engineering. So, bone tissue engineering is actually based on the understandings of the bone structures, bone mechanics, and tissue formation that is focused to get the goals to induce new functional bone tissues. In other words, is to successfully regenerate or remodeling or repair bones. Knowledge of the bone biology and its development is quite essential presently. On this bone tissue engineering, there are several methods used on this application. First is the metal, such as examples stainless steel, and the uses of this stainless steel is to total replacement joints and plates. And second material is through the ceramic, such as synthetic polyaptate CO galactite, and the natural, such as chitosan and galactane. The uses of these ceramic materials is for the bone extenders, scaffolding, and drug delivery. And next is the composite, such as PHA and PSP. So the uses of these composite is for the composite scaffold composites itself. Next is the strategies for bone tissue engineering. In general, bone tissue engineering implants are constructed of a carrier which is known as the scaffolds and biological active factors. And these biological active factors can be combinations of cells and protein that stimulates whole cells. So the ingredients of tissue formation is based on cells plus with the growth factors and absolutely the scaffolds. As we can see, the figure here is illustrations of bone tissue engineering. We have to extraction of the cell, and it will be added with the scaffolds. Scaffolds here is very important for biomaterial in order to occur the bioactivities with the cells in the bone layers. And these integrations of scaffolds and cells will later result upon regenerations. Next, we will focus on bone tissue engineering, especially for bone regeneration. The first is the recuperation process. Recuperation process is like the healing process for the bone. After grafting or implantations of the scaffolds to the affected bone, the recuperation process will start to occur, and normally this will take like the durations like several weeks or several months. And the next is the dynamic process. Before recuperation process, bone will start and will be continuous remodeling in line with various concentration and variables such as stress bone, And this dynamic process will be balancing the bond creations and resorptions. As we can see, the figure here is based on osteoclast and osteoblast. Osteoclast and osteoblast must depend each others for the focus of bone formations. Next is the remodeling process. So remodeling process is actually it is mediated by bone cell producing osteoblast and bone resorption cell, which is known as osteoclast. And osteoblast will cause osteoclast to break down bone matrix to initiate the remodeling process. As we can see that there are two sections here for the bone resorption and bone formations. And the bone formation is actually taken actions by the osteoblast, and bone resorption is responsible by the osteoclast. And osteoblast and osteoclast is very important for each other in order to produce new bone formation or bone regeneration. Next subtopic is the scaffold composite. So scaffold composite is very important in bone tissue engineering. So scaffolds are 3D dimensional materials, which is by constructed in order to provide a structure to develop tissues and in order to allow cells to adhere, proliferate, differentiate, and secrete of extracellular matrix frameworks. As we can see, the figure here is actually the 3-dimensional materials of scaffolds here. Next is the scaffolds. Properties such as osteoconductivity, porosity, and biodegradation are very required in the process secrete extracellular matrix in order to success in bone tissue engineering. So similarly, angiogenesis, supporting attachment, bone formation, enhancements, and proliferation of osteoblasts are also forms of supporting properties to achieve this stage. So they actually have a various of scaffolds that have been used and applied this recently for bone tissue regeneration, such as polylactic CO glycolic acid, which is known as PLGA. And next is tricalcium phosphate, TCPA, or known as bypass. Third is polycaprolactone, PCL. Next is hydroxyapatite, HA. Next is collagens, coal, and ketosane. Hydroxyapatite and ketosane are very similar characteristics, which is they are from the same families of biomaterial. Next, we will enter this next subtopic, which is the polyhydroalkanoids, which is known as PHA. So PHA actually have a wide range of chemical and physical characteristics, which is itself depends on the monomer content. So PHA described as a water insoluble, and it is hydrophobicity, melting point, plus transition temperatures, and degree of crystallinity are all used to define polymers in general. Besides, PHA is a partly crystalline nanoparticles polymer that is actually generated by the microbes somewhere in the cell compositions or known to be cytoplasm. As we can see that in the figures here, this is the illustrations of PHA, and this is the chemical equations of the PHA. The mechanical characteristics of PHA are determined by its monomer compositions, chain length, and distance between the R group and the ester bond. As we can see, the molecular structures of the PHA here is R group, and N is the chain length. The physical modifications of polyhydroalkanoids is being practiced nowadays, and which is most of the processes are essentially based on blending or mixing process. which is we will apply this process for our project. Next subtopic is the nano calcium phosphate. So calcium phosphate are calcium cations and phosphate anions minerals, and they make up the majority of the inorganic materials in around 16% of all native human bones. And they are actually have several classifications and clarifications of human bones. And calcium phosphate characteristic influence bioactivity in osteoblasts, such as adhesions, proliferations, and new bone formation. Because of its osteoconductive and intrinsic competence, osteoinductive properties, calcium phosphate has been widely employed in bone regeneration applications, and the activations of osteoblasts and osteoclasts is regulated by the release of calcium and phosphorus, and which aids bone repair. So it means that calcium phosphate is very important in osteoinduction and osteoconductions, which is specifically the actions of the osteoblast and osteoclast for bone remodeling process. Here is the illustration of the calcium phosphate. And intrinsic factors is from pHa. Surface modification is from chitosan, and environmental factors such as ion temperatures. So all surface modification, intrinsic factors, environmental factors are very important for the osteoinductivity, osteoconductivity, and biodegradability of the scaffold, which is importantly for calcium phosphate. So this process will be improved for the scaffolds in bone tissue engineering. Plus, as we can see the figures here, there are two scaffolds which is subtracted and not without substitute of calcium phosphate. So this context is the subtractions of bypass calcium phosphate. So this is the without, and this is the coated PCB. For the surface morphology by CEM, as we can see that the screening electron have shown that the moleculars of the scaffold is larger, whereas the coat BCP of scaffolding shows they are more discrete and smaller, which is nearly about 400 nanometers. So it is actually important for the calcium phosphate in the scaffolding, because calcium phosphate take responsibility to trap the osteoclast in osteoconduction and osteoinduction process. Next subtopic is the chitosan CH. For scaffolds in bone tissue engineering, widely practicing and using chitosan as one of its vital material. So the applications of scaffolds in bone tissue engineering nowadays is very important and relevant to use, because chitosan plays a very important role. And these materials are only applied with other polymers to ceramic in particular process, such as the combinations chitosan and PHA, for example. And next is biopolymers, including chitin and others, have been used to boost the mechanical strength and structural integrity of chitosan-based material. Besides that, chitosan are extracted and derived from the acetylation process in order to get and produce chitins from seashells, such as prawn shells. As we can see that this is the illustrations of the chitosan. So chitosan-based bioactive material for tissue engineering can be divided and can be applied in various applications such as cartilage tissue engineering, skin tissue engineering, tissue fixations, and others more, and especially for bone tissue engineering. Next subtopic is the thermal properties. So based on these illustrations of figures, the TGA curves in figures A shows the composite scaffold thermal stability, whereas the DSC curves, which is these figures B, shows the composite scaffold's breakdown temperatures. So the TGA and DSC curves of the composite scaffold as a functions of temperature may be derived. So the curves of TGA and DSC is very important for to get the derivations of the temperature functions of temperature. Besides that, all of the composite scaffolds have determinable thermal characteristics such as the beginning degradation temperature, and 15% weight loss. And besides that, all of the composite scaffolds have determinable thermal characteristics such as the beginning degradation temperature, and 15% weight loss and ultimate degradation temperature. Next subtopic is the microstructures. So microstructures, surface appearance, and chemical contents of scaffolds were examined using scanning electron microscope and energy dispersive spectroscopy. So SEM analysis of scaffold samples revealed that all types of scaffolds had 3D porous structures with irregular shapes called micro bore holes. As we can see the figures here, there are 3 samples of scaffolds and there are 3 results of image sketched by through SEM. So each of the samples have a different porosity and have a different structures and pore holes. Next is we entering the chapter 3, which is the methodology. So for subtopic number 1 is the project flowchart. As we can see, the figure here is the subtraction of the flowchart. For the figure here, we start with start. Next is the preparation of 5 samples of biomaterial. Next is the blending process, and next go to the crushing process. So all of this stage process is actually from the stage 1, and next process is going to the FTIR method and going to the determination of thermal properties using TGA and DSC method. So this is described as the stage 2. Next process is the examinations of microstructure using SEM method, and after characterization process, we do the analysis and discuss the results, and the projects will be end. So this phase, the examination is actually in the stage 3. Next subtopic is the material. So as we can see the table here, it is the tablet of the 5 sample, which varies of 5 weight percentage of 3 biomaterial. So the preparation of sample comprises the starting material of BHA pellets, nano-calcium phosphate powders, and chitosan powder that is initially provided. So the first sample we will blend with the preparation of 100 weight percentage BHA with the existence of nano-calcium phosphate and chitosan into composition. So the second sample and the rest is respect to the designed presented composition as shown in the table. Next subtopic is the variations of the composite. So as we can see the table here is the parameters needed for mixing. So all 3 materials are blended together using a bar blender machines, and the parameters have been set according to table 1.2. which is the speed of linear rotation is nearly about 30 rpm with the temperatures of 130 degrees and the durations for about 15 to 20 minutes. So the process were repeated until 5 samples. Next subtopic is the scanning electron microscopy. So as we can see, the figure here is the illustration of the instrumentations of SEM tools. So the scaffold has a high porosity and excellent connectivity between pores. According to scanning electron microscopy, the pore size ranges from 50 to 600 micrometers. And through SEM, the porosity of sample can be evaluated and determined by using various powder concentrations. At the surface, the porosity of the scaffold was determined to be in the range of 39 to 47.5. When particle concentration is increased from the porosity of the scaffold does not change considerably. Next subtopic is using the method of the TGA and DSC method. So this figure is the illustration of the instrumentations of TGA and DSC tools. So using differential scanning current DSC and thermal gravimetric analysis TGA, a thermal analyzer was utilized to detect changes in weight and heat flow as a function of temperature engineering application TGA. And the relationship between scaffold mass and temperature can be measured via thermal gravimetry, and the weight loss of the sample can be determined by analyzing the disintegration of the scaffold using DSC. Hence, the thermogram of the scaffold revealed similar behavior with mass losses due to polymer degradation. So we can measure the degradations of the scaffolding by measuring its weight loss and the thermal temperature. Next subtopic is the FTIR. So FTIR is a spectroscopy and imaging which can be used as analysis partially in homogeneous material like both in the form of section or homogeneous powders, which is offering both quantitative and qualitative information from both organic and inorganic tissue components. So this method will provide a snapshot of structural and material features that are mostly dependent on bone turnover as well as the tissue changes caused by metabolic and non-metabolic disorders. So FTIR analysis and molecular weight studies were performed on all melted scaffold. So on these figures is the illustration of the instrumentations FTIR tool. That is for the whole chapter, for chapter 1, chapter 2, and chapter 3. So that is all for me, and thank you very much.